Alright, so, by now you've probably mastered all of the one-step mole conversions that we've needed to do, and you're pretty familiar of the way that we get from moles to grams, moles to particles, moles to liters. Now, we're going to get a little trickier, and we're going to go into two-step mole conversions. Now, the trick here is that you're going to have a situation where you don't have one conversion that you can make. For instance, you don't know, and don't try to tell me that you know, the number of grams in a liter of carbon dioxide. It's just not going to happen. You could figure it out, but you really don't want to get into that. So, sometimes you're not going to be able to convert directly in one step. Now, the nice thing is that all of the quantities that we've discussed so far are related to the mole in a fundamental way. When we're talking particles, we can relate it by Avogadro's number. When we're talking about grams, we can relate it by the molar mass. When we're talking about liters, we have the concept of the molar volume at standard temperature and pressure. So all of these things relate to the mole, and so the rule that we're always going to follow when we do these two-step conversions is get moles first. I'm going to underline it just for emphasis. So now, what we're looking at in our first example is how many grams are in 1.20 times 10 to the 21st molecules of propane. Now, propane is the stuff that you use at home in your gas grills, and it's a very useful thing to heat things. It's all is involved in cooking, in home heating, things like that. Now, what you didn't know, but what I will tell you, is that the formula for propane is C3H8. So, just like any other conversion problem that we've done so far, the first and most important thing we need to do is to write out the conversion factors. So, we're going to write those right down here. It's going to get to the point where you're going to find this part pretty tedious because you're already going to know. But I encourage you to always write out the conversion factors because it's always useful to have them in front of you. That way you make sure you put in all the right values and you make sure you have things squared away. So, the first one that we need, it looks like we're going to need to deal with molecules. How many molecules are in a mole? Of course we know that 1 mole of any substance contains 6.02 times 10 to the 23rd particles. In this case, since we're dealing with a molecular compound, and since it asks us about molecules initially, we can assume that they mean molecules. So, the second conversion factor that we need will allow us to get grams. So, we're going to say that 1 mole We're having some technical difficulties, so forgive me for a moment. We're going to say that 1 mole, there we go, is equal to 44.11 grams. All I did to do that is I looked up the mass of carbon on the periodic table and multiplied by 3. That's 12.01 for those of you following along at home. And then I took the mass of hydrogen, which is 1.01, and I multiplied it by 8. Add those together, and you get 44.11 grams. You can feel free to check me on that, but you can trust me that that's the molar mass. So, now that we've written out our conversion factors, the next step is to make a grid, and to actually solve the problem. Now, do not just start randomly putting numbers into your calculator, because odds are pretty good you're going to write them in wrong, at least now as you're starting out. So, we're going to write out a grid, and we're going to start with the value that we're given. So, in this case, the value that we're given is 1.20 times 10 to the 21st molecules. Now, the first conversion factor that we're going to put in, essentially we're talking about a ratio here, needs to do one very important thing. Namely, get rid of this unit, molecules. So we need to be able to cross that top unit out here. And how are we going to do that? Using the first conversion factor right here. 1 mole equals 6.02 times 10 to the 23rd molecules. Now, You learned in math class way back in the day that the only way to cancel things is to have one unit on the top and the other on the bottom. So in this case, we're going to make sure that Avogadro's number goes on the bottom. Just like that. And then, what we're going to end up doing is we're going to put 1 mole on top. Remember, the two values that you put in this ratio, in this box in the grid right here, have to be equal to each other. So, if we check out our progress to this point, we know we're right about this because we're able to cross out molecules as a unit. If we weren't able to do that, then we'd have to go back to the drawing board. But so far, so good. So now let's see what step we need to do next. Now, the question asks us how many grams. So, our final conversion factor has to get rid of moles, because this is the unit we have here, and needs to give us grams as a final unit. It just so happens that we've already written that out, because we've already figured out the molar mass. So 1 mole goes at the bottom. That way we can cancel it out, and I'll go ahead and put my nice red line through that now. And on the top, we're going to put the mass of 1 mole, the number of grams in 1 mole. And there we go. So now, as my Algebra 2 teacher, Mr. Sperry, once said back in the day, all we have left to do is plug and chug. We have 1.20 times 10 to the 21st. We're going to divide by 6.02 times 10 to the 23rd, since we find it on the bottom of our next fraction. And then we are going to multiply by 44.11 grams. Now, since we started out with 3 sig figs in our initial measurement, we have to have 3 sig figs in our answer, and our final answer is going to look like 0.0879 grams of propane. Again, can't say enough how important it is to include proper units in your answers, not only to get full points on quizzes and tests, but because it's very important that you know what units you have. The goal of dimensional analysis, and these mole conversions are a type of dimensional analysis, is to have the right units in your final answer. And it looks like, according to what we've done here, that we have just that. So there's your answer. There's your first example of 2-step mole conversions, with another coming up. Thanks for watching.